So today I'm going to start by showing you how to construct a confidence interval after doing an independent samples t-test. So remember that we use the independent samples t-test to test if two sample means are different from one another. After doing the t-test, if we end up rejecting the null hypothesis, we can construct confidence intervals to estimate how large that mean difference that we found actually is. So here is some sample data. Let's say I've already done a t-test on it and rejected the null hypothesis. We have two samples here, and I've given you the sample means, the sample standard deviations, and the size of each of the samples. And what I want you to do is to construct a 95% confidence interval for the difference of these two means. And I'm going to show you how to do that. Now first of all, remember that a confidence interval is just a point estimate plus or minus the margin of error. So that means we're going to end up with two values, a lower bound and an upper bound. And we're going to be 95% confident that the mean is somewhere between those 2 points. So these are the equations for the lower bound and the upper bound in a t-test. Notice that we already know the sample means for sample 1 and sample 2, the sample standard deviations for sample 1 and sample 2, and the sizes of sample 1 and sample 2. So I can put in the pieces that we already know. And all we really need is that thing, t alpha divided by 2. If we had that, we could find the lower bound and the upper bound. So let's do that. First of all, we're constructing a 95% confidence interval. That means that there's 5% left over. We have an alpha of 0.05. So we're going to use an alpha of 0.05 when we're looking up our t-value. And remember, because we're doing a t-value, we also have to look up the degrees of freedom. Now in an independent samples t-test, we're going to have 2 degrees of freedom, one for each sample, one for sample 1 and one for sample 2. Now in this case, the degrees of freedom for each sample is 29. Usually in an independent sample t-test, when you're looking up the t-value, you will use the smaller degrees of freedom. In this case, they're both 29, so I'm just going to use 29. So I'm going to go to my t-table, and we're going to use an alpha of 0.05 and degrees of freedom 29 to look up our t-value, which in this case would be 2.0452. So, constructing a 95% confidence interval for this information, we would use a t of 2.0452. And now we have everything we need to calculate the lower and upper bounds. So if I solve for this information, I get a lower bound of 6.65 and an upper bound of 9.35. So what this means is that we are 95% confident that the mean difference between sample 1 and sample 2 lies somewhere between 6.65 and 9.35. And that's all it means to construct a confidence interval for an independent samples t-test.